We've been working a lot with sine and cosine as of late, as it pertains to the unit circle, how we use it to solve real-world application problems, working with triangles. Today we finally take a look at, well, what type of graphs would these produce? Because with any function there's a graph that goes along with it, am I right? Worked with linear functions, we've worked with quadratic functions, the parabola. Today we look at these two. And these are the only two trig functions out of the 6 ones that we take a look at. So we're going to get them both done in the same day. A little review before we begin. If I ask you for the sine of theta, that is associated with which variable, x or y? Okay, now you're guessing between the two.
It's y.
It is y. Very good.
Told you, Jason.
If we go to cosine of theta, cosine of theta, that then by default is our x. And this is the key role in when we break down the graph of sine and cosine. It's, well, how is the y value changing as it pertains to the sine, and how is the x value changing as we move across the x-axis as it pertains to cosine. So let's go ahead and start with the sine function. Sine, we have said, is the change in y, or it pertains to the y value. You know, if we start over here at 0 and we work our way up to pi over 2, pi, 3 pi over 2, and then eventually back to 2 pi, with the sine function, we're looking at, well, how is that y value increasing or decreasing? You know, if I give you that point right there, what's your y value of that ordered pair? Well, it's 0, right? Because it's right on the x-axis. And that's why with the sine function, we always start at 0. Or the origin. That'll be helpful to keep in your notes. This graph you don't have to necessarily put into your notes, but I would definitely put sine function start at the origin, because that's going to be a key start for you. What this graph is just going to help us do is to start developing the idea behind this wave that apparently is going to take place. So we start at 0, and now I'm going to go counterclockwise like we do with the unit circle, and I'm going to start working my way up to pi over 2. Now notice the scale that we have over here is in our radian measures, pi over 2, pi, 3 pi over 2, and 2 pi. So we go from 0 to pi over 2. Notice what's happening to my y value. Getting bigger or smaller? It's getting bigger. It's increasing, right? Here we increased a little bit. Well, there we increased more. We increased more there. And eventually, what value are we approaching? 1, right? Because our unit circle has a radius of 1. So that's why when we go from 0 to pi over 2, we're approaching that 1 value right there. Now as we go from pi over 2 to pi, now what's happening to our y value? It's decreasing, right? Here it was really tall, okay? Here it's getting smaller, and eventually it's back down to 0, right? So from pi over 2 to pi, we're dropping all the way down to 0. As we look from pi to 3 pi over 2, now what type of y value are we looking at? Negative, and we're going from 0 to -1. Therefore 0 down to -1. And lastly, if we finish to go from 3 pi over 2 back to 2 pi, we're going from -1 and working our way back up to having a y value of 0. And that's why we work our way back up there. And again, if we wanted to, we could continue to pull this point around the unit circle, and notice it would continue to make this curved shape here. It would continue on to the right forever. And there is the graph of sine. Do we get the idea behind it? Biggest thing I want you to take away is the fact that as we graph this thing, it's all about your change in y. What type of y value are we looking at? Because you've been told that since day 1. Real quick, let's look at cosine. Cosine pertains to the x value. As we move this point around the unit circle. You know, if we look at our point right here at 0, pi over 2, pi, 3 pi over 2, back to 2 pi. Notice what type of x value do we have here? What's this ordered pair? Well, again, it's 1, 0, right? So what's my x value? It's at 1. So that's why with the cosine function, we're no longer starting at the origin, but now we're going to start at 1 or possibly negative 1. So for the cosine function, here's what I would put: start at, that's considered to be the max or the min. And I will explain that a little bit more specifically here in a little bit. But for right now, max or min. As we begin to work our way around the unit circle, as I go from 0 to pi over 2, what's happening to my x value? It's getting smaller, right? Here it was really long, but now as we go there, it's getting smaller and smaller and smaller and smaller to the point where it doesn't even exist. So we are going from 1 to 0. So there it goes. As we go from pi over 2 to pi, now what's happening to my x? What is it approaching now? Negative 1. Very good. So we're going from 0 down to negative 1. As we go from pi to 3 pi over 2, my x value is slowly coming back to 0. And to finish from 3 pi over 2 to 2 pi, notice my x is gradually going back to 1. And there is the result of the cosine function. Beautiful, correct? Biggest things you want to take away from this is the sine is the y, the cosine is the x. Sine starts at the origin, cosine starts at your min or max. Let's keep going. Properties that we can always use with the sine and cosine functions. For the graphs of y is equal to a sine bx, this is our form that we always work with. The a value is always ahead of the trig function. The b value follows right behind that trig function. It's the same idea for cosine, which is nice. They didn't move the variables on you. Still a, then b. If we take a peek at example number 1, what would your a value be here? It would be 3, and what would your b value be? 4. We will use those here in a little bit. First thing we can use them to find is the amplitude. Amplitude is the overall height of your wave. You know, is this a really tall wave, or is it a very compressed wave? You know, that's the overall height of it, amplitude. It's simply the absolute value of a. The b value is going to help determine the number of cycles that's going to take place. Again, notice that this wave is going to repeat itself. It's going to go up and down and up and down and up and down. And that b value tells us just how many cycles are going to occur between 0 and 2 pi. The period, or the cycle, can be found by taking 2 pi divided by b. The period is the length of which it takes to complete one full cycle. So for example number 1, they're going to start off nice and easy. We're going to start by finding the amplitude of this function. If we go back to what our chart tells us, the amplitude is the absolute value of the a value. Which again, here's your form. y is equal to a sine of bx. A value is obviously 3, so the absolute value of 3 is 3. Period. How do we find it? Well, we take 2 pi and divide it by b. That's what our chart tells us to do. B value is 4. Therefore, the period is pi over 2. So if we take a look at the graph, hopefully this is making sense to us. The amplitude, again, is the overall height. Notice that it goes up to 3 and down to -3. So in a sense, the amplitude is half the height. Okay, -3 to 3 is 6, divided by 2, there's your 3. The period is just how long does it take to complete one repetition or one cycle. Notice if I trace this one here, it's not until I get to this point right here, I have completed one cycle. And then I can make copies of this thing and attach it to the end, and then I would have my function. Where did that take place? Well, there's pi. So it took place at pi over 2. And that's what we found. And it's with that we know enough now to start graphing this thing. Graphing sine and cosine is a 4-step process. Number 1 is you need to find the amplitude. And I would write out step 1, step 2, 3, and 4 just like I'm going to. Amplitude. Height is, or A value is 3. So the absolute value of 3 is 3. Easy enough. Find the period, I need to take 2 pi and divide it by b. B value in this case is a half, so we need to be careful here. Complex fractions multiply by the reciprocal, which is 2 over 1, therefore my period would be 4 pi. Everybody okay with that idea? Step 3. Now what we want to do, now that we found the period, is we want to divide the period into force. We always start at 0, and we always end with whatever the period happened to be. Here it was 4 pi. So I would do it this way, 0 to 4 pi. And then if you're going to divide it into fourths, just like your box and whisker plot, how many points did we find? 5, correct? Your min, your max, your median, your lower and upper quartiles. Same idea. Min, max, what's between 0 and 4? 2. Therefore 2 pi. What's between 0 and 2? 1. Therefore 1 pi. And what's between 2 and 4? 3 pi. Think of it as numbers, and then you can just throw the pi symbol in there. And the last thing is we need to determine where are these points going to fall. They call it the pattern. We begin by looking at the trig function. It was sine, right? And we said sine starts where? Origin or min slash max? Origin. So if we start at the origin, we're going to start at 0. And now it works just like the working with the slope of a line. You know, if my slope is positive, is it going to go up or down? Up. If it's negative, it's going to go down, right? So we look at our A value. The A value here is 3, which indicates a positive 3, right? So now we're going to go up to the max. If it was negative 3, you would write min right here. Go down to the minimum value. So we go from 0, or the origin, up to the max. We'll come back down to 0. We'll go down to the min. and then we'll end up back at 0. You'll get more comfortable with this pattern as you go along. And now we have enough to graph it. Once again, the amplitude was 3. So 1, 2, and 3. 1, 2, and 3. Now I'm going to give myself plenty of space. Dylan, if you want to, you can hand out graph paper to everybody if you would. I'm going to go every other unit as I go to plot these points or to make my scale. This right here, the step 3, this is your scale for the x-axis. So if you want to put that in your notes. Step 3 is always the numbers that you put on the x-axis. You know, that right there is going to be my pi, 2 pi, 3 pi, and 4 pi. And you don't have to label every single one of them if you don't want to. But if you do, there's your pi and there's your 3 pi. It gets a little messy if you include all those. So sometimes that's why I only include those two. You want to put the tick marks for all 4 because that's going to help you identify where you're going to put these points though. So we have our y-axis scale in place, we have our x-axis and scale in place. Now we just need to plot our points according to the pattern that we came up with. The first one was 0. Then we go to our max. We go back down to 0, down to our min, back to 0. And the best you can, draw your curve going through the points. Come test time, I will be looking for those 5 points. I will be looking for your y scale as well as your x scale. 5 points just like your box and whisker. And at this point, this completes one cycle. We could just repeat it and go from there. Do I need to go back? Last one, let's take a look at a cosine function. I'll go a little bit quicker here now that you know it. Step number 1, what did we find? Yeah, because the good news is, regardless of whether it's cosine or sine, your 4-step process is still the same. Step number 1 was find the amplitude. Absolute value of 4 is 4. Step 2 was the period. 2 pi over b. B value is 2. Therefore, the period, the length at which it takes to complete one cycle, is pi units. Step number 3, take our period and divide it into force. So we start at 0, we'll end at our period, which is pi. And notice what's my coefficient here? 1. Okay, so we're going from 0 to 1 essentially. Halfway between 0 and 1 is a half. So half pi, or pi over 2. What's halfway between a half and 0? 1/4. Therefore 1/4 pi. What's halfway between a half and 1? 3/4. Therefore 3/4 pi. And for step number 4, we need to determine what pattern we're looking at. Okay, cosine. We said at the beginning cosine starts where? Min or max, very good. Now again, think of your slope. If this is a positive 4, which one of the two do you think it is? Well, it's going to be your maximum value. If this was a negative 4, then it would start at the minimum, correct? Negative 4. So we do start at the max because it's positive. We start at that very high value and then we go down to 0. Then we go all the way down to the min, back up to 0, and finish once again at the max. Once again, you should have 5 of these down there. Your options down below here will always be max, 0, or min. Those are the only 3. And you need 5 of them. Amplitude is 4, so there's 4. 1, 2, 3, and 4. Let's draw on our X scale. Again, I'll give myself plenty of room, so I'm going to skip 1. We finish here at pi. Halfway is pi over 2. We start at the max. Go to 0. Down to the min. Back to 0. Up to the max. One, 2, 3, 4, and 5 points.